Okay, so here we're still doing trigonometry, as before, and we saw the definitions of the trig functions. Okay, as before, we've seen that. So what I wanted to do now was go through this example. I don't remember if I went through this example or not, but it wouldn't hurt, I think, to go through it again. Here, basically what we have is we know that a trig function at an angle is a fifth, okay? So sine of theta is 1/5. We do know that theta is between 0 and 90 degrees. So it's acute. An angle is acute if it's between 0 and 90 degrees. What we want to do is determine all the other trig functions, okay? We want to know all the other trig functions at theta, but we're not going to figure out what theta is, okay? But we don't have to, which is nice. Now, how do you actually get the other trig functions? Excuse me. What we have to do, remember, is we form a right triangle where one of the angles is 90 degrees, making it a right triangle. Another angle is going to be theta. Essentially, you want to make a right triangle where sine of theta is a fifth. That's what you want to do. Okay, so we have sine of theta is a fifth here. Now, do we have that? Well, remember, sine of theta is opposite over hypotenuse. Okay, so opposite, the side opposite theta, the length of it is 1. The hypotenuse is always the side opposite the 90-degree angle. It's always the side opposite the 90-degree angle. Okay, so in this case, this is the hypotenuse, and its length we're labeled as 5. We labeled it as 5. So we have sine of theta is 1/5. Opposite, hypotenuse, 1/5. Sine of theta is 1/5. But we need to know what this side is, right? In order to get all the trig functions, we need to know all sides of the triangle. So how do we get this side? Pythagorean's theorem. Pythagorean's theorem, okay? Okay, so what do? We have x squared plus 1 squared is 5 squared. Remember, normally in Pythagorean's theorem, you have a squared plus b squared is c squared. C is always the hypotenuse. A and b are the legs of the triangle, right? So we have a squared. So excuse me, we have a is x, b is 1, and c is 5 in this case. A is x, b is 1, c is 5. How do we get x? Well, we know that by Pythagorean's theorem, x squared plus 1 squared is 5 squared. So we have x squared plus 1 squared is 5 squared. Okay, that's good. Then what do? Well, we know that 1 squared is 1, 5 squared is 25. We want to figure out what x is, so we want to isolate it. That's why I'm subtracting 1 from each side. As you can see, subtract 1 from both sides, we get x squared equals 24. 25 minus 1 is 24, as you can see. Then we have x squared equals 24. Well, if x squared equals 24, what does x have to be? You take square roots. You get x equals the square root of 24. Now, I simplified this because we know that 24 has 4 as a factor. 4 is a perfect square. So the square root of 24 is not simplified. So I'm simplifying it. I'm taking the 4 out. We're left with 6. Square root of 4 times 6, that's the square root of 4 times the square root of 6, which is 2 radical 6, 2 square root of 6. But you could have left it as the square root of 24 if you wanted to. You only have to simplify if I tell you to. So we know what this side is. Now we can get all the trig functions. But before I do that, are there any questions so far? All right, well, let me keep going then. So we have the side over here is 2 times the square root of 6, right? It was the square root of 24. But again, we simplified that to be this, 2 square root of 6. Okay, that's good. So we know sine of theta is opposite divided by hypotenuse, 1 over 5. Cosecant, right? That's 1 over sine of theta. 1 over means you invert, you flip. So 1 over 5 becomes 5 over 1. And 5 over 1 becomes just 5. If you divide by 1, it's really the number itself. It doesn't change anything. Cosine of theta, what's that? Well, that's adjacent over hypotenuse, right? Adjacent over hypotenuse. So 2 radical 6 divided by 5. That's cosine of theta. Secant is 1 over cosine, right? 1 over, you invert, flip, you get 5 over 2 radical 6. 5 over 2 radical 6. Okay? Then tangent of theta is opposite over adjacent. Opposite over adjacent. So that's 1 divided by 2 radical 6. Cotangent is 1 over tangent, right? So that means you invert this, so you get 2 radical 6 over 1, which is 2 radical 6. So we get that. All right. Any questions on this? Yes.
Do you always have to find it for each of like the cosine, tan, sin? Like you have to find all of those every single time?
Unless I tell you which ones to find.
Okay.
So if I say find all the trig functions, I think I said that in this one. Did I? Yes, find all the other trig functions. Then you have to find those. Sometimes I might say find just cosine and tangent. Then you only have to find those 2.
Okay.
Does that make sense?
Yeah. But
Good.
some of them, like you're gonna have to find like, will you have to find like a cosine in order to find like the sequence 0, like that one? Would you have to like?
You mean this one down here?
Yeah.
You could use the definition directly because this is actually hypotenuse divided by adjacent. You could do that if you want instead. Okay. I just chose this to make because for me it's easier to remember it this way. So
okay,
it's up to you. Okay. Does that make sense or?
Yeah.
Okay. Cool. Good. Good question. Any other questions at all? This came up in the other class. Someone asked, could I have put theta up here instead? You could do that if you want. Theta could be up here. The only thing is, though, is that 1 and x would have to interchange here. Because remember, when we say opposite and adjacent, it's always relative to the angle. So if I put theta up here, the opposite side would be down here. And adjacent side would be over here. Okay? I mean, I always put it over here just out of, I guess, convention, so to say, or out of habit, but just letting you know. I mean, the hypotenuse is always opposite the 90-degree angle, no matter what. Okay, that's good. All right, so that's an example. All right, so that's example 4. The next one, it's a little bit different because now you have tangent. I want everyone to try this though, so I'm going to pause the recording. It'll take about